6.3 is looking at ionic bonding, ionic compounds. So first of all, remembering what an ionic compound is, it's going to be a compound that's made of ions, a positive and a negative. You have to have a positive and a negative because their goal is to cancel out and equal 0. So it may take 2 negatives and a positive. The total charges have to equal 0. So if I have a +1 and a -1, that would equal 0. Maybe I have a -2 and I have 2 atoms or 2 ions that are +1s, that would all add up to 0. So our ionic compound is going to use ions to make our compounds. A formula unit is when we have that compound, and those ion compounds are going to build up on themselves. They're not just going to be found as one unit typically. And so the smallest ratio where they can actually still be that substance, that compound, is the formula unit. But when we find them, they're going to be built up upon themselves. So NaCl makes a salt, sodium chloride compound, but when you find it, it's going to have multiple compounds together. One of the really cool things about ionic bonding is they make nice patterns when they build up. So if you think of a crystal, if you're growing a crystal or like a cube of salt or sugar, those are going to look like little crystals and have very specific shapes. So here you can kind of see patterns in those building up of those formula units. And it's called lattice energy when we're trying to make those or break them apart. I mean, if you think of like lattice work in a yard, a fence, it's typically white. A lot of times you see them around pools or gardens, but they've got that crisscross pattern, a repeating pattern. And so that's how ionic compounds are. If we have positive lattice energy, that's going to be the energy gained when we're forming the crystals. If it's negative, that's energy given off when the crystals are formed. When we're looking at an ionic compound versus molecular, you can see the difference in the structures. So this has the ionic nice repeating patterns, where in a molecule, they're just kind of all over the place. Forces between molecules are going to be a lot weaker than ionic compounds. Molecular compounds have lower melting point and often are going to be gases at room temperature, whereas ionic compounds are typically going to be solids. They are often going to be hard, brittle type structures. When they break, they're going to break like on a nice smooth plane. If you think about breaking a crystal, it's not going to be jagged where the break is. It's going to break nice and smooth. These are not good conductors, and they do dissolve in water. And then finally, polyatomic ions. These guys are kind of special because they're held together by covalent bonds, but the structure itself, the ion itself, has an overall charge. So it's a group of atoms held by covalent bonds, but they have an overall charge making them an ion.